Greetings, welcome to this new video about Kirchhoff's laws, KCL and KVL, Kirchhoff's current law and Kirchhoff's voltage law. Given the electric circuit with R1 30 ohms, R2 40 ohms, R3 1 ohm and R4 1 ohm, and we have two voltage source V1 45 volt and V2 80 volt. The question using Kirchhoff's laws first to calculate the currents through each resistor and to deduce the dissipated power in each resistor. Let's go to the solution. We start always with step number 1 to choose the direction of the currents. I always told you to choose the direction of the current arbitrarily. This is I1, the current through the resistor R1. I2 is the current through the resistor R2. And finally I3 is the current through the resistor R4. We go now to step number 2 is to identify the polarity of each resistor. We know that the current go always from the high potential to the low potential. That means this is positive and negative of R1, positive and negative of R2, positive and negative of R3, and finally positive and negative of R4. After we finish step number 2, we go to step number 3 is to apply Kirchhoff's current law KCL. We can write here a node A. We see also that I2 is entering the node, I1 and I3 leaving the node. We can write KCL at A, I2 is equal to I1 plus I3. After we finish applying Kirchhoff's current law KCL, we go to step number 4, applying Kirchhoff's voltage law KVL. Let's choose the different loops we are going to use here. This is loop number 1 and this is loop number 2. In loop 1 we can write R1 I1 minus V1 plus R3 I2 plus R2 I2 is equal to 0. We obtain 30 I1 minus 45 plus 40 I2 plus I2. Finally, we obtain 30 I1 minus 45 plus 41 I2 is equal to 0. We go now to loop 2. We can write V2 minus R2 I2 minus R3 I2 minus R4 I3 plus V1 is equal to 0. We obtain 80 minus I3 plus 45 minus 40 I2 minus I2. We see here minus 40 I2 minus I2 is minus 41 I2. We obtain finally 125 minus I3 minus 41 I2 is equal to 0. After we finish applying Kirchhoff's laws KCL and KVL, we obtained 3 equations with the 3 unknowns. The question now is how to solve those equations in order to obtain the current I1, I2 and I3. Let's start with equation number 2. We have 30 I1 minus 45 plus 41 I2. We can find I1 is 45 minus 41 I2 over 30. We obtain finally I1 is 1.5 minus 1.36 I2. Here we obtain equation A. We can see that I1 is written in terms of I2. We go now to equation number 3. We have 125 minus I3 minus 41 I2 is equal to 0. We can write I3 in terms of I2. We obtain finally I3 is equal to 125 minus 41 I2, and I will call this equation B. We go now to equation 1. By substituting A and B in equation 1, we have I2 is equal to 1.5 minus 1.36 I2 plus 125 minus 41 I2. Finally, we obtain 43.36 I2 is equal to 126.5. We obtain I2 is 126.5 over 43.36. We obtain I2 is 2.918 amps. We go back to equation A. We replace I2 by its value. We obtain I1 is equal to negative 246 amps. We go to equation B. If we replace I2 with its value, we obtain I3 5.36 amps. After we finish calculating the currents, we go to calculate the dissipated power in each resistor. We know that the dissipated power in a resistor is equal to the resistor multiply the current square. Then we write P1 is equal to R1 I1 square. We obtain 183.027 watt. And we have P2 is R2 I2 square. We obtain 338.72 watt. P3 is R3 I2 square is equal to 291 watt. And finally P4 is equal to R3 I3 square is equal to 569 watt. After we finish calculating, we do simulation using SPICE simulator in order to verify our calculation. Let's go together to SPICE simulator. Here is the simulation using SPICE simulator. We see here is this is the value of R1, 30 ohms, R2, R3, our voltage source V1, resistor R4, and the voltage source V2. Let's go to analysis. This say analysis, and we do calculate nodal voltage. We can see here that the current I1 is negative 249, I2 is 292 amps, and finally I3 is 5.4 amps. Those values are almost the same value we have done with calculation. Thank you for watching this video. If you have any question, do not hesitate to contact me by email or leave a comment under this video, and I will try to answer you as soon as possible. Have a nice day, take care, and bye bye.